Welcome to the campus of the University of Kansas, home of the Jayhawks. Nestled alongside Mount Oriad in beautiful Lawrence, Kansas is the KU School of Engineering, home of the EcoHawks. The EcoHawks program was formed in 2008 with sustainability being its core focus. Apart from its work in electric vehicles, the EcoHawks are also developing ways to make the energy infrastructure smarter for our cities. To do this, the EcoHawks have developed and built a small-scale smart grid. Project leader Mickey Clemon explains more.
The smart grid system is important because we can save energy with it. We can reduce the demand for coal-powered energy, and we can optimize the use of renewable energy. We can also include electrified vehicles into this system and balance out all of the demand.
Solar and wind energy, two of the most abundant types of renewable energy sources in the world. Successful capture and incorporation of these types of renewable energies is important to the future success of the grid. The EcoHawks are incorporating these two types of renewable energy sources into their small-scale smart grid system, a system that incorporates different sources of energy, different energy storage methods, as well as different loads, to model the smart energy grid of the future. The system consists of a student-built solar panel and wind turbine that represent the renewable energy contributions to the grid, as well as a gas-powered generator that represents the traditional coal-fired power plant energy that is currently in the grid. These energy sources can be used to either directly power a load on the system, or the energy can be stored for later use in a few different ways. The first of these ways are two lead-acid batteries that are found on the small-scale smart grid model. These batteries represent a battery bank that could be used to store energy on a large scale. The other method for storage in the system is an electrified vehicle battery pack.
One of the novelties of using electrified vehicles in the smart grid is that when you're not driving it, you could potentially take the energy stored in the electrified vehicle's battery pack and discharge it onto the system. So you could use it to run your lights or your popcorn maker or your refrigerator or whatever it may be.
The popcorn maker that Mickey alluded to represents one of the loads on the smart grid model. The popcorn maker represents any household appliance that could have the need to draw energy from the grid. The other load that is on the grid in the EcoHawks small-scale smart grid model is the monitoring equipment. What puts the smart in smart grid is the ability of the system to change where it is getting its energy from, as well as for the user to see what is going on in the system. And for their small-scale model, the EcoHawks have done just that. In the system, there are many sensors that feed into a main computer program. The display of this program gives the user all the information they could want to know about the system, from the wattage of the solar panel to the charge level of the batteries. Having this display is critical to the development of a smart grid. Also critical to the development of a smart grid is the ability for the user to determine where the energy comes from and where the energy goes. On the small-scale model, this has been accomplished with a series of switches. On a large-scale smart grid, those switches would be replaced with relays, and the user would simply select all of their desired energy settings on a user-friendly energy settings interface similar to that of a household thermostat.
Our system is the future. Future electric grids will incorporate both renewable energy and electric vehicles. Central generation isn't going to go away. And so how do we manage all of these different components in the electric grid is what we intend to find out and present to the world.
The EcoHawks at the University of Kansas, developing a smarter, more sustainable future.